What current flows through the 4 ohm resistor? So this circuit system has two networks. It has a series network and it has a parallel network. And we want to find the current flow through this 4 ohm resistor. Okay, so we want to begin by recalling the equation to find anything in a circuit, which is the voltage of the circuit is equal to the current of the circuit times resistance of the circuit. Okay, next thing you want to know is that in a series circuit, you have the same current. And in a parallel circuit, you have the same voltage. Now, you want to find the current flow through this resistor. To do that, we need to find this. This is just this equation applied to this. So divide R sub 4 on both sides. You get the current for the 4 ohm resistor is equal to the voltage of the 4 ohm resistor over the resistance of the 4 ohm resistor, which we know is 4 ohms. Now, we need to find the voltage of the 4 ohm resistor. And to do that, the voltage of the 4 ohm resistor is going to be equal to the voltage of the circuit, this, subtracted with the voltage of the 6 ohm resistor. Voltage of the 6 ohm resistor. Okay, so does that make sense? This is going to be this subtracted by this because unlike in the parallel circuit where this is the same voltage, this is in the series circuit. So it's a series network, therefore it won't have the same voltage as this. So in order to find this, you do this, subtract this, okay? And you don't have to draw the delta here. You could just leave it as V sub 4. Okay. But this just represents the voltage of the 4 ohm resistor, okay? Now, we know that the volt for circuit is 8. So we can remove this and write 8. Now we want to know what V sub 6 is. And in order to find that out, we need to turn this equation again to apply for this. So V sub 6 is equal to I sub 6 times R sub 6. So V sub 6 is going to be equal to I sub 6 times R sub 6. We know that R sub 6 is 6. Okay? Now, because this is a series network, the 6 ohm is in a series network, if we find I sub 6, we can find V sub 6. So in order to find I sub 6, series network have the same current. Therefore, we need to turn this parallel resistor into one resistor, allowing us to find the current of this. Because then this would be series, it would be series, series have the same current. Okay, so let's find out the resistance for these two. So, because these two are in parallel, we want to find R parallel, which the equation for R parallel is going to be 1 over R1 plus 1 over R2 and so on. So we have R1 is 2, R2 is 4. So 1 over 2 plus 1 over 4 is 3 over 4 is equal to 3 over 4, which means that 1 over R parallel is 3 over 4. R parallel would be flip of that, 4 over 3. Crucial information. Okay, once you know that this is 4 over 3, you can say that these two equates for 4 over 3. This will allow us to find the current for I sub 6, because we know that the voltage of the circuit is equal to the current of the circuit times resistance of the circuit. And over here, you could rewrite it as voltage of the circuit, which is 8, is equal to current of the circuit times resistance of the circuit. Resistance of the circuit would simply be the series added together. So since we turn this parallel into a series, 4 over 3, we just do 6 plus 4 over 3. 6 plus 4 over 3 is 7.33, around that. So you would then have, let me remove this, 8, let me try this, 8 is equal to I circuit times 7.33, divide 7.33 on both sides to find the current of the circuit. 8 over 7.33 is 1.09. So the current for the circuit is 1.09, which if we know the current for the circuit, we know the current for the 6 resistor. 6 ohm resistor, because in a series circuit, it has the same current. So V6 is going to be equal to 1.09 times 6. Okay. 1.09 times 6. So this number times 6, you get a 6.548, which we can round it up. It's around 6.55 amps. So once you know this, crucial information as well, you can plug this V6 into here. Okay, and solve for V sub 4. So let me erase this. You have V sub 4 is equal to 8 minus 6.55. So 8 minus 6.55 is going to be 1.45. Okay, so V sub 4 is equal to 1.45. Which this is also crucial information because we can plug it into here, right? So now the current for the 4 ohm resistor is going to be equal to 1.45 over 4, which, plug that into a calculator, 1.45 over 4, you get 29 over 80, or 0.0 0.3625. Therefore, the current flow through the 4 ohm resistor is going to be 0.3625 amps. And this is your answer.